Hey, what's going on? I am back with another video. This video will cover your test review, and I hope it helps. Let's get started. Alright, on this first example right here, it says convert degrees to radians, radians to degrees, and find the exact value. So we use the 180 over pi conversion, alright, which is 8 times 180. All over 5 because those pi's are canceled out, and I get a whopping 288 degrees. Right here for 364, we're going to convert that to a, alright, right here, 364 degrees, we're going to convert that by multiplying by pi over 180. Alright, so we end up with 364 pi over 180, alright, which we can reduce to 91 pi over 45. They both are divisible by 4. 91 over 45. 91 pi over 45, excuse me. Alright, right here, pi over 12. Right here we multiply by 180 over pi. Alright, which is going to give us, the pi's canceled, we're left with 180 over 12, which reduces to 15, so it's 15 degrees. And lastly, we're going to convert this by multiplying by pi over 180. Alright, 180, excuse me, sorry guys, that's 180. Alright, and so now we have 28 pi over 180, which equals 7 pi over 45 right there. Alright. Moving along, let's look at this next example right here. So this, alright, for this example right here, it says find all 6 trig functions with the angle on the unit circle. Alright, with an angle on the unit circle. First of all, we got to find this side right here. So this is opposite, this is adjacent right here, which we don't know. So I'm going to call that x, and this is hypotenuse. So we go 3 squared plus b squared equals 5 squared. Alright, and then we're going to get 9 plus b squared equals 25. Alright, we subtract 9 on both sides. B squared equals 16. And then we take the square root on both sides, and we're going to get 4. So b equals 4. So that's 4 right there. So now we know this adjacent side is 4.
Making a video right now?
Yeah. So sine is going to be opposite over hypotenuse, which is opposite. Let me label our part. Opposite adjacent hypotenuse. So 3 over 5. Cosine is going to be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. Cosecant is going to be the inverse of sine, which is 5/3. Secant is the inverse of cosine, which is 5/4. And cotangent is 4/3.
Alright. Next right here it says find the measure of the indicated angle. Exact answer. So we need to find an angle. Well, if we look at the sides that were given, we have this angle is hypotenuse, this side is hypotenuse, this is adjacent. So that would be cosine for this angle. And cosine equals adjacent over hypotenuse. So cosine of theta equals 2 over 3. And in this case, guys, you cannot take the cosine of theta. So what we're going to do is we're going to use an inverse. All right, to find our angle. And when we put that in our calculator, hopefully you got your calculator right here with you, you end up with theta. There we go. theta equal to 48.2 degrees. Alright, right here, we have opposite over adjacent, which means that's the tangent identity. And again, you cannot take the tangent of theta. Sorry about that. Alright. So we're going to end up taking the tangent inverse, 14 over 19. And when we do that, we get theta equals 36.4 degrees. Alright. Now, down here, we have coterminal angles. $700 degrees. So, minus 360. Alright. That will give me 340 degrees. So this is one angle that is coterminal to 700. Alright, it's positive. So it's fine, guys. I know I subtracted first, but it's positive. It's a positive angle. Alright. And then one negative. So I'm going to do 340 minus 360 and get negative 20 degrees. So again, guys, this angle is coterminal. This is coterminal to 700, and this is coterminal to 700. Alright, it's negative. I needed one positive and one negative. For this one, alright, it's in radian, so I'm going to leave my answer in radian form. So for this one, and a lot of the time, guys, you get discouraged by the fraction. You don't have to. Let me show you. I'm gonna 7 power 12 is not on the unit circle. So right here, I'm gonna add 2 pi. All right, because 2 pi is 360. If you remember, 2 pi equals 360. Okay, but it's radian. All right. And I'm going to do 7 pi over 12 minus 2 pi, okay? So now look, I know it's a radian, guys. But look, in your calculator will do it for you. Let me show you. So, in the calculator, remember it was 7 pi over 12? But if I put 7 over 12, right? And then I add 2. All right, I know I don't have the pi right here, guys. And it's okay. I'm still going to get math fraction. I'm still going to get my fraction. You see that? 31 over 12. So how we translate that is we translate that to 31 pi over 12. All right. Because again, I'm adding that fraction to that whole number. All right, 31 pi over 12. And if I do the same thing, excuse me, if I do 7 over 12 for 7 pi over 12 minus 2. Math fraction. Alright, right there, negative 17 over 12. Which means my answer is going to be negative 17 pi over 12, like that, okay? Alright, right here we can do the same approach. And that was big, 97 pi. So we gotta go 97 pi over 36, that's really large. So I'm gonna go minus 2 pi first because I need a positive and a negative. So I'm gonna just work down. 97 pi minus 36, you can do the exact same steps. Uh-oh. 97 divided by 36 minus 2. Oh, math fraction. So 25 over 36 is going to be a positive 25 pi over 36. When you do that, make sure you don't forget your pi, okay? All right, and then I need to keep going. That's still really large. Excuse me. So I'm going to do the same thing. 25 pi over 36 now. Oops. 25 pi over 36 minus 2 pi. Keep it going. Oops, didn't mean to do that. So the answer, I'm going to use that minus 2. Math fraction. Negative 47 over 36. So that's my negative right there, guys. Negative 47 pi over 36. Alright. Now lastly, I have negative 618. Well, I'm going to add 360 to this because that's negative. Alright, 360 degrees. In doing so, I get negative 258. Alright, so this is still negative. But if I take negative 258 and add 360 again, I'll get my positive coterminal angle, which is 102 degrees. So there's your negative, there's your positive. Alright. Now, let's go to this equation right here, which says find the arc length or angle measure based on a circle A, all right, with a radius AC of 1.6. So we know we have a circle. They just told us. There's a circle, all right, with this point right there, AC, all right, AC, with that radius R is 1.6. Now, if you remember the equation, all right, S stands for arc length. All right, R is your radius, which we have, and theta is our angle. Okay, so knowing that, jump down here to 11. It tells us if the angle formed by point D, so there's another point here, D, if that angle right there, all right, as a radius, point D on the circle, and the radius AC has an angle measure of 2.5 radians. What is the length of DC? So what is that arc length? So remember, we use the equation, our arc length equals theta times R. But we know what it is. All right, we know what theta is. Theta is going to be 2.5, and R is 1.6. So if we multiply the two guys, we're going to get 4 meters. All right, I said meters. I don't know why I said meters, guys. Did it say meters? I don't know. But there you go. All right, the arc length DC. I'm just gonna write it right here. Arc DC is 4. All right. All right, here, what is the length of arc DC with the measure of an angle DAC is 3 radians. So again, same equation. All right, theta, we know what theta is 3, and we know the radius is 1.6. All right. So in this case, DC, our DC will be 4.8. All right. Now right here, 13, and again, I'm just using this same equation, guys. Right there. All right, arc length equals angle times radius. It's solid. All right. Right here, the arc DC. So now we know what the arc is. This time the arc is 5.024. right? It says, what is the radian measure? Well, I don't know the angle, so I don't know theta. All right, but I still know R. R is 1.6, you see that? So I'm going to divide by 1.6 because that's multiplication. And when I do that, I get my angle is, or theta, guys, it's 3.14 radians. 3.14 radians. Alright? Alright, so solve each triangle round to the nearest 10th. Well, first we're going to start by finding side A. I have two sides. I have this side and the hypotenuse. So I'm going to use Pythagorean Theorem. A squared plus B squared. Right here, you know what, since it's A, I'm just going to leave it as that. A squared plus 6 squared equals 10 squared. Remember, your hypotenuse is always C, all right, in this equation. So A squared equals 30, sorry guys, plus 36 equals 100. Now we're going to solve for A by subtracting 36. So A squared equals 64. And now we take the square root on both sides and we get A equals 8. So we know little a is 8. Alright. Now that green dot. Now we can find our other sides. We know that's 8. Ooh. So I'm going to find angle A. Angle A, this is opposite, and this is hypotenuse. So I'm going to use sine right here. I'm going to go sine of A, because I don't know what it is, equals opposite over hypotenuse. And again, you can't take sine of A. What I can do is take the inverse side of this ratio 8 over 10. And when I do that, I get angle A, and it says round to the nearest 10th. It's going to be, here, let's punch in our calculator. We're doing sine inverse of 8 divided by 10. 53.1 degrees. Alright, make sure your calculator too is in radian mode. I mean degree mode, sorry, degree mode. Alright. So 53.1. So 53.1 degree. And now all I do is remember 1, 2, 3. These two angles right here equal 90 degrees. This angle A plus angle C is 90. So if I do 90 minus 53.1, alright, I'll get 17 point. I'm sorry. I'll get 36.9. So this is 36.9. So there we go. We just completed this triangle. Let's look at this one. Alright, we have 90 and 38. We need to find angle R. And remember again, these two angles equal 90 degrees. So 90 minus 38 is going to be 52. So this is 52 degrees. Now I need to find one of my ratios, and I'll just start by, I'll find S first. Alright, so finding S, I'll use angle 38, so it's opposite. And this side right here that I'm giving is adjacent, so that's tangent. So tangent of 38 equals opposite S over adjacent. Well, how do I isolate the S? I multiply by 22 on both sides. And 22 times tangent of 38 is going to give me 17.2. And now I'm going to do the same thing for finding Q. Alright, using this angle here, 38. This is adjacent. And I'm sorry, this is hypotenuse. Oh my goodness, that's hypotenuse. So we have hypotenuse and we have adjacent. Alright. So what we do is hypotenuse and adjacent, that would be cosine. So we have cosine of 38 equals adjacent over hypotenuse. Alright, or in this case Q. So I need to multiply by Q on both sides. Right? And then I'm just going to divide by cosine of 38. So that's what you punch in your calculator, 22 divided by cosine of 38. And when you do that, you're going to get 27.9. 27.9. So there we go. We completed that triangle. Alright. Ramps. Ramps, the Uniform Federal Accessibility Standard specifies, that the ramp angle used for a wheelchair ramp must be less than or equal to 4.78 degrees. The length of one ramp is 16 feet. The vertical rise is 14 inches. Alright, so I'm going to do you a quick sketch real quick. Oh, I thought I could make this thing longer. Hold on. Alright, so here's what I did. The length of one ramp is 16 feet. We got a ramp that's 16 feet. The vertical rise is 14 inches. Alright, it says estimate the ramp's horizontal distance, this side, and then its ramp angle. We don't know this. I know they gave us an angle. We're trying to see if this ramp meets that standard. Okay? Trying to see if it meets that standard. So, what I'm going to do first is I'm going to find this length. Let's figure out how long this is. Alright, I'm going to use Pythagorean Theorem. So, well, yeah. I'll use Pythagorean Theorem. But before I do that, I said this is feet. I need to convert that to inches. Alright, so there is 12 inches in a foot. So 12 times 16 is going to be 192. So it's 192 inches. So now everything is in inches. Alright. So now I'm going to do Pythagorean Theorem, and this is the hypotenuse, this is the opposite side. So I'm going to go 14 squared plus b squared equals 192 squared. Alright? And in doing so, I'm going to get 196 plus b squared equals 36,864. When I subtract 196, b squared equals 36,668. And now I square root both sides. And when I do that, I get A equals 191.5. So this is 191.5. So I have the horizontal slope. Alright, this is the horizontal slope. Guys, this is the horizontal distance. Alright, horizontal distance right here. Now I just need to find that angle. And to find that angle, sorry about that. To find that angle, we need to use like opposite over hypotenuse, which is sine. Alright, so if you go sine of theta equals opposite, and remember I'm using inches, guys, over 192. Alright, what I get is I can't take sine of theta, so I use the inverse. Alright, and when I do that, I get 4.2. Alright, so this is 4.2. 4.2 degrees. So, the question was, does the ramp meet the Uniform Federal Accessibility Standard? Yeah, it does. That 4.2 is less than 4.78. So the answer is yes. And we proved it mathematically. Alright. Alright, let's keep this train going. Right here, you are in a hot air balloon. Alright, that's 600 feet above the ground. Alright, so above the ground, hot air balloon. Alright, there's a little basket. Alright, that's 600 feet. Alright, it says if your angle of depression, meaning guys, my angle of depression is 20 degrees. This angle here is 20. That means this angle is 20. They're alternative angles. Alternate interior angle, excuse me. Alright. It says how far from the point on the ground, which means this point right here, alright, below the hot air balloon, alright, how far is the line? Alright, because here's your friend. Your friend's right here. Alright. So if the angle of depression from your line of sight to your friend, alright, is 20, how far from the point on the ground below the hot air balloon? Alright, so the hot air balloon point is right here. So we're looking for this side right here. We don't know what that side is. So we know this is 20. So if this is 20, this is 20. My angle of depression. So now I'm in my triangle. I'm going to use opposite and adjacent. So that's going to be tangent. So if I use tangent of 20, that equals opposite over adjacent. And I need to solve for x. So multiply by x on both sides. And then divide by tangent of 20. I should have said tangent. That's terrible. Alright, that cancels. Alright, and when we punch that in, we get 1,648.5 feet. Alright, so 1,648.5. So from this point, from where you are to your friend, is 1,648 feet, guys. Alright, for this problem here, find the exact value of the six trig functions given for the following angle. This is 240. 240 is on your unit circle. Alright, the point for unit circle for 240 degrees, if you look, is -1/2 and -1/2 and negative square root of 3 over 2. So now find your six trig functions. Remember, sine is y, cosine is x, and tangent equals sine over cosine. Alright, which is, hold on, let me make this thinner so I can read. It is negative radical 3 over 2 divided by -1/2. But remember, we got to keep this, change that, and flip that. So that gives us, keep the top, change the multiplication, and flip that. So, a couple of things happen here. The negative is going to cancel out. The 2's cancel out. So I'm left with radical 3 over 1, which is radical 3. So tangent is radical 3. Now, the inverse of sine is cosecant, which is -2 over radical 3. When we flip it, which we need to rationalize, move the radical to the top. Move the radical to the top, literally. Put that radical at the top. Now, what is the number from underneath the radical? 3. Leave that at the bottom. No, you cannot cancel that out because it's not under a radical. Move the radical to the top, leave the number at the bottom. Secant of theta is the inverse. So the inverse is -2 over 1, which is -2. And then lastly, cotangent. Let me use another color. Cotangent right here is the inverse of tan. Alright, so I'm going to go back and look right here. See 1 over radical 3? Alright, or that if you did that, right? I'm going to flip that 1 over radical 3, which we need to rationalize again. Move the radical to the top, right? Keep the number from the radical at the bottom. So that's cotangent. Alright, there's your 6 trig identities. Alright, 315 is also on the unit circle. That point for 315, if you look at your unit circle, is radical 2 over 2 and negative radical 2 over 2. So now, find sine. Sine is y. Cosine is x. Oops, look at me. Radical 2 over 2, see? And tangent would be sine over cosine. So, negative radical 2 over 2 divided by radical 2 over 2, right? Now that's the same thing, just negative. So radical 2 over 2 divided by radical 2 over 2, all right? But the negative is there, so it's -1. Cosec is the inverse right here. So -2 over radical 2, which I rationalize by moving the radical to the top, leaving the number at the bottom. Hey, look, see those 2's? They cancel out. So negative radical 2. Secant is the inverse of cosine. So 2 over radical 2. We rationalize. And then that cancels. And then cotangent. The inverse of -1 is still -1. All right. Now, for 21 and 22, we're going to find the 6 trig identities. Except this time, guys, this is a point. All right. This point right here, -x, +y, is in the second quadrant. So I'm going to make my triangle real quick. I'm going to make my triangle in the second quadrant. Remember, theta is from the origin. And so we have negative, this is x, this is y. So -x and y, all right, up 3. That's a +3 because the point's right here. -4, 3, right? So left 4, up 3. And then Pythagorean Theorem. -4 squared plus 3 squared equals c squared. That's 16 plus 9. That's 25 equals c squared. Square root both sides, you get 5. Alright? So now I have my triangle and I can find my 6 trig identities. But this time, remember, you got to use the triangle rules. So opposite over hypotenuse. Cosine, adjacent over hypotenuse. -4 over 5. Tangent, opposite over adjacent. Right, -3 over 4 because the 4 is negative. All right, cosecant. Just flip this, inverse or hypotenuse over opposite. Secant is the inverse of cosine. So you have hypotenuse over adjacent. And cotangent is the inverse of tangent. So -4/3 or adjacent over hypotenuse. All right, right here, this point right here, +x, -y. 6, negative 3. My point is right here. 6, negative 3. Right? Pythagorean Theorem, to find my hypotenuse. 6 squared plus negative 3 squared equals c squared. 6. Sorry. I'll make that thinner. 36 plus 9 equals c squared. That's going to be 45 equals c squared. And then square root both sides. You have the square root of 45 equals c squared. Well, I'm going to rationalize this. All right, if you remember, that's 9 times 5. All right, so 9 times 5 equals c squared. Square root of 9, oh, I'm sorry, it's not c anymore. I took the square root. It's not c squared anymore, excuse me. That's 3 radical 5. So 3 radical 5 is my hypotenuse. Don't put a decimal here, guys. You're going to lose points. Sine. Sine is going to be, actually, let's use another color. Sine is going to be opposite over hypotenuse. Now, see those 3's? They cancel. So negative 1 over radical 5, which we need to rationalize. Move the radical to the top. Leave the number at the bottom. Negative square root of 5 over 5. Cosine is adjacent over hypotenuse. Well, again, 6 divided by 3 is 2. Right? And we're going to rationalize that. Move the radical to the top. Leave the number from the radical at the bottom. Tangent is opposite over hypotenuse. I mean over adjacent, sorry guys, which is a negative 1/2. Cosec is the inverse of this. Alright, so hypotenuse over opposite, which you see that cancels, so it's just negative radical 5. Alright, or you could have took this one right here, see that? Flip it, it'll be negative radical 5 over 1, which is negative radical 5. Secant is the inverse of this, so if I just flip this one right here, alright, or I'm going to do the work that will show you. 3 radical 5 hypotenuse over adjacent, which 3 over 6 is 1/2. Right? 1/2 right there. Which again, I told you could just flip that. And then cotangent is the inverse of tangent. So if you were to flip it, 6 over negative 3, you'll get negative 2, which is the inverse of that. Okay? We're almost there. Alright, right here. When you look at these type of problems, guys, alright, it says using one trig function and a quadrant, find the remaining trig functions. So, guys, hopefully either you memorize that chart I gave you that told you where everything is, or you can just kind of use a little logic, which I'm going to use. Right here, I start right here. Cosine theta is greater than 0. If a number is greater than 0, it's positive. So cosine is positive. And now, sine, I look at my sine. Sine is negative 1/2. That means sine is negative, guys. It's right there, it tells me it's negative. So where is cosine positive, positive to the right, negative sine, which means negative y value, positive x, negative y. That's down here, guys. Fourth quadrant. Alright, so now I can use sine. Alright, if I use my sine, my triangle rules, because I made a triangle. Alright? That means this is opposite. This is hypotenuse. Sine is opposite over hypotenuse. So I don't know what the adjacent side is, but I know opposite. See how this goes down? Alright, that's going to be -1. Because I gotta apply this negative. So -1, hypotenuse is 2. Alright. Now I'm going to find this side by using Pythagorean Theorem. Alright. So, 2 squared. Alright, here, let's go -1 squared plus b squared equals 2 squared. So that's 4. That's 1. 4 minus 1 is 3. So b squared equals square root. B equals 3. I'm jumping ahead of myself. B squared equals 3. And then we take the square root. So this is square root of 3. Alright. Now I'll find my trig functions. We know what sine is. Sine is -1/2. See? Cosine is going to be adjacent over hypotenuse. Man, that looks familiar, doesn't it? Tangent. Tangent equals opposite over adjacent. Which, when you rationalize it, becomes -3 over 3. Alright, whatever this angle is definitely from the unit circle. I can tell you that. Because look, sine, cosine. That actual point would be -315. No, -3 pi, -pi over 6. Alright, -pi over 6 is what that is. Anyway, keep going. Cosecant, the inverse of this, -2, or hypotenuse over opposite. Secant, the inverse of this, or hypotenuse over adjacent, which we rationalize, right? Oh, sorry, over 3. Look at that. I'm rushing, trying to get done, making this video early in the morning, guys. So I can go to work and teach you. Anyway, we got cotangent, which I can just flip this one. Alright, or adjacent over opposite, which is -3. Alright. Alright. 24 now. Same rules apply. We're going to first figure out excuse me, what quadrant this is in. Alright. Sine is less than 0, which means that's negative. Now, tangent, a little more involved right here, guys, but it's not scary. If you remember, tangent is sine over cosine, right? So we know this is negative. It told me right here. Well, this is positive. So for this to be positive, I need a negative over a negative. Negative over negative is positive, right? So that's positive. So that means cosine is negative as well. So where's sine negative, cosine is negative? It's in this quadrant right here. Third quadrant, excuse me. So now apply your triangle rules. This is opposite over adjacent. So we have -3 and -5. And why did I make this negative? Because I need a negative x, negative y. That's the only way to make this positive. See, if a negative divides by a negative, it's positive. And then my hypotenuse. Alright. Pythagorean Theorem. So we have -5 squared plus -3 squared equals c squared. 25 plus 9 equals c squared. 25 plus 9 is 34. And then we take the square root of both sides. So we end up with square root of 34. Alright, and that doesn't simplify. So now I'll just look at all my rules, alright? Sine is -3 over square root of 34, which we rationalize. -3 square root of 34. Oh man, I almost put 5. Over 34. All over 34. Alright, cosine is -5 over square root of 34, which we rationalize. Then tangent, -3 over 5, -5, opposite over adjacent, which is a positive, 3 over 5. All right. Cosecant, the inverse or hypotenuse over opposite. Sorry about that. So you can just flip that. Secant, the inverse or hypotenuse over adjacent, and then cotangent, adjacent over opposite, which you can just invert that. Man, I'm sorry, man, if you're watching this video still. It's long, I know. My apologies. Alright, we got 6 more problems. Arc cosine of negative radical 3 over 2. Let me get a unit circle. Alright, I want to get a unit circle here that we can use, okay? Alright, arc cosine. Alright, or cosine inverse, doesn't matter, it's the same thing. Of negative radical 3 over 2. So remember, the first thing when you're dealing with these arcs, guys, is you need to label this side of the unit circle. So this is going to be, instead of 11 pi over 6, I'm going to go negative 11 pi over 6. Alright, and then right here, instead of 7 pi over 4, I'm going to negative pi over 4. Instead of 5 pi over 3, I'm going to use negative pi over 3. And instead of 3 pi over 2, negative pi over 2. Alright, now I'm ready to work. Arc cosine. Well, remember, arc cosines is top half. Alright, it's just the top half. So just this part. Alright. So, let's see here. Negative 3 pi over 2. Remember, cosine is your x value. So where is this next value? Negative 3 pi over 2 right there, which is this value right here, 5 pi over 6. There you go. Alright, right here. Tangent inverse of radical 3. Alright, tangent inverse of radical 3. So radical 3. Tangent, remember, tangent is only on this side, arc tangent. Only on this side. Alright, in the yellow. Anyway, radical 3. You gotta remember, guys, right here, sine over cosine, pi over 6. I mean, pi over 3, sorry, that's pi over 3. I said pi over 6, that's pi over 3. If you remember, right, check yourself. Radical 3 over 2 divided by 1/2. Keep change flip. Right there, radical 3. See? Here, let's move this down so we can have it. Alright, right here. Arc sine of radical 2 over 2. So I'm going to address this first. Alright. Arc sine of radical 2 over 2. Well, sine inverse is the yellow over here. And remember, this is the y value. Alright. So where's y radical 2 over 2? Right there, pi over 4. So this answer right here is pi over 4. This is pi over 4. But I gotta find sine of pi over 4. Alright, so if I look back at my unit circle, sine of pi over 4 is radical 2 over 2. So there's our answer, radical 2 over 2. Alright, for this side,
Notice this says tangent. This does not say tan inverse or arctan. So I'm not restricted to just the yellow portion of the circle. All right, this is tan of 5 pi over 6. So I go to 5 pi over 6. I know this is small for you. All right, right there, 5 pi over 6. Tangent is going to be sine over cosine. So 1/2 divided by negative radical 3 over 2. I'm just going to tell you that's going to give you negative radical 3 over 3. All right, I'm just going to tell you. Check it. You check it. If you don't believe me, do sine over cosine. So now I have arctan of this because that equals that. All right. So where it is this? Remember, we gotta look. That's the tangent inverse. You gotta look in the yellow now. All right. So the point's gonna look just like that. All right. But negative. Hey, there goes negative pi over 6. Because if I undo that, all right, I'll end up with those points, y over x. All right, which is right there, negative pi over 6. All right, 2 more. Cosine inverse of negative 1/2. All right, so then again, look at the top half, the green. Where's cosine negative 1/2 right there? 2 pi over 3. So this is 2 pi over 3 right here. Right? So now I find sine of 2 pi over 3. Again, I'm not looking for the inverse. So I'm looking for the actual the y value of 2 pi over 3. So I go to 2 pi over 3, radical 3 over 2. Right there. All right. And then we got one problem left. Yeah, we got one problem left. That was 30. Let's go to 29. So tangent, guys, again, that's tangent 3 pi over 4. That is not the inverse. So I go look on the actual unit circle. I'm not restricted to the yellow side. Where's 3 pi over 4? Right there. Tangent. Radical 2 over 2 divided by negative radical 2 over 2. That's negative 1. So this right here is negative 1. Right? So now I want cosine inverse of negative 1. All right? So now look at your top half of your circle because that's inverse. So I only look at the top half. Where's the x value? Negative 1. Right here at pi. So the answer here is pi. All right? Well, if you stuck around this long, again, it's the longest video I ever made for a review, but this one required a lot, so it's thorough. I hope it helped, and good luck on your tests.